Okay, kids, we are on page 153 using the mole concept in chemical equations. I want to read the very first part of this page. It says the real importance of the mole concept is revealed when you look at how it relates to chemical equations. Remember that a chemical equation is really a recipe. By looking at the coefficients which appear to the left of the substances in the equation, we can learn how much of each substance we need to make a reaction occur. It's just like using a recipe. You have 2 eggs, you have a quarter cup of sugar, you have a half cup of butter, you have 2 cups of brown sugar, you mix it all together and you add some flour, salt and baking powder, and you've got cookie dough. Okay? That's all that we're doing here. We're saying if we combine these different chemicals together, these different elements, these different compounds, that we can form something new, and that's what we're going to be using. So this is so important that they reiterate this. It means they state this again. It's highlighted, bold-faced, about 2/3 of the way down your page. It's centered. In chemical equations, the coefficients which appear to the left of each substance tell you how many moles of that substance must be used in making the chemical equation. Then it goes on and says, as long as you can balance chemical equations, you can determine the recipe necessary for making that chemical reaction occur. Let's say that you want to make sulfuric acid. There is a chemical, since sulfuric acid is a compound, it's a formation reaction, chemical reaction, and you can say, okay, I'm going to add this and this and this, combine it together and make whatever that stuff is. Okay, so I don't know. There they are. Matt didn't have his keys. Okay, so if we'll go ahead and continue on, what we're going to have is problem 5.10, 5.10. This is on page 155. This says a chemist, I should say 5.10, page 155. A chemist obtains a 122.3 mole sample of ammonia. Which is NH3. If the chemist allows this sample to decompose, how many moles of hydrogen gas will be produced? Decomposed, how many moles of hydrogen gas? How many moles of hydrogen gas will be formed? Now there are a couple things going on here where you have to put information together that you already know. First off, what's a decomposition reaction? When something decomposes, it's a decomposition reaction, which means you're taking what you have to begin with, nitrogen and 3 hydrogen atoms bonded together make ammonia. But ammonia is going to decompose. Now remember, we said that when we're decomposing, decomposition reactions, that we're going to get down to the elements when we're working within the confines of this class. So ammonia is going to decompose into nitrogen and hydrogen. Now, is this right, what I have here? Nitrogen and hydrogen? Well, no, it's not, because both nitrogen and hydrogen are diatomic, homonuclear diatomics. And let me look here and make sure that I'm exactly correct in what I'm saying. Yes. So that means that they occur in nature, bonded together in pairs. So now we have to make sure that we get this decomposition reaction balanced. Well, I've got 2 nitrogen over here, I only have 1 over here. So let's say if I take 2 molecules of ammonia, what do I have? That I have 2 N's Here I have two N's. I have 2 times 3 H's, which is 6 H's. How many H's do I have here? I only have 2. If we use 3 hydrogen molecules here, diatomic molecules, the equation is balanced. So now, how many moles are we going to have of hydrogen gas? Well, this tells us that 2 moles of ammonia produce 1 mole of nitrogen gas. Also, it tells us that 2 moles of ammonia decompose and producing 3 moles of hydrogen. So the relationship between this says we have a 2 to 3 relationship. So okay, let's go ahead and continue with what we had. We found out that 2 moles of ammonia, when they decompose, they produce 3 moles of hydrogen. So if the chemist allows a sample of 122.3 moles of ammonia to decompose, we want to find out how many moles of hydrogen gas that's going to produce. Now watch what I do. And this is different than the method that he shows you in your chemistry book. Go ahead and go through your chemistry book, see if it makes sense to you, use it. You might be able to think of a ratio, might be able to understand the work a little bit better doing it this way. Let's try this. And pay attention to me here. Okay, we learned from our balanced chemical equation that 2 moles of ammonia, when they decompose, they produce 3 moles of hydrogen gas. Okay? 2 to 3 ratio. If 2 moles of ammonia produce 3 moles of hydrogen, and we have 122.3 moles of ammonia, how many moles of hydrogen are going to be produced? We're going to have X moles of hydrogen. We can cross multiply. We're going to find out that all of these units here are going to cancel out, so that we only have the number of moles of hydrogen gas. So what we have, just using numbers, 2 is to 3 as 122.3 is to X. We're going to cross multiply. 2 times X is equal to 3 times 122.3. X then, 2X divided by 2 is going to be equal to 3 times 122.3 divided by 2. Let's go ahead and get our trusty calculator out and see what we end up with. This is problem 5.10, 122.3. 3 times 122.3 divided by 2 is equal to, X is equal to 183.45 moles of hydrogen gas. 183.45 moles of hydrogen gas. Well, what is our, how many significant figures can we have here? Can I have 4 significant figures? So it's going to be 183.5 moles of hydrogen gas would be our solution. And you see how easy that is? This is not something that is anywhere near close to as difficult as they make it out to be. If you just make a ratio, 2 ammonia produce 3 hydrogen. 122.3 ammonia then are going to be equal to how many hydrogen? Okay? That would be the end of the final problem that I'm going to do, I believe, for Chapter 5, for Module 5. Okay, I'm going to read page 156. The section you've just completed is an introduction into the most important aspect of chemistry, which is relating the quantities of chemical substances in a chemical reaction. And this is called stoichiometry. Stoichiometry is what we're going to study in Chapter 6. I'm going to make videos and y'all will so be able to do that.